Assalamualaikum and hi everyone. So now let's take a look on the discussion on our test 2 for ICT502. Okay, so test 2 consists of 3 questions and you have to answer all questions and please answer in English. So now let's take a look on our question number 1. Based on the following schedule 1, there are 5 different transactions that are running concurrently in the database. At time 6, there is a checkpoint being done by the system. However, during time 11, there is a failure in the database. So by the way, you are given schedule number 1 over here. So if you take a look, you are given the transaction, time, action, which table involved, which row and columns involved, and what is the old value and what is the new value. Okay, so based on the schedule above, answer the following questions. Draw a recovery timeline for schedule 1. Okay, so now first thing first, please take a look at the time. Okay, please take a look at the time. We have time number 1 up until time number 11. So you have to draw the time first. Okay, time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. Okay, and we have time 11. Okay, so after you have got the time, please take a look at which time we have the checkpoint. Checkpoint is at time 6. So means over here at time 6 we have a checkpoint. Then we have a crash at time 11. So means at time 11 there's a failure. Okay, so after you got all the time, the checkpoint and also the failure, now please take a look at how many unique transactions do we have in this transaction. So if we take a look, we have transaction 1, 2, 3, 4 and 5. So means you have transaction 1, 2, 3, transaction 4 and transaction 5. For each transaction, we need to determine when is the start time and when is the finish time. Okay, so let's start with transaction number 1. Transaction number 1, they start at time 1. So means transaction 1 start at time 1. So this is the start. Okay, then find when transaction 1 commit. Can when transaction 1 commit. So if you take a look, transaction 1 commit at time number 4. Time number 4, transaction 1 commit. So this is the timeline for transaction 1. So we repeat the same process for transaction number 2. Okay, for transaction number 2, they start at time 2. Can start at time 2, and at what time transaction 2 finish? So we find the commit point of transaction 2. Transaction 2 here, there's no commit point. So if you take a look up until the end, transaction 2 haven't commit. So means up until the crash, transaction 2 is still doing the transaction. Kan transaction 2 is still doing the transaction. Okay, so now let's determine for transaction number 3. Transaction number 3 start at time 4. Okay, it start at time number 4, and when it finish, find transaction 3 commit at time 7. Kan time 7 is over here. Okay, so now we draw a timeline for transaction 3. Okay, so we repeat the same process for transaction number 4. Kan when transaction number 4 starts at time 8. Kan transaction number 4 start at time 8 over here. And when it finish at time 10. Time 10, transaction 4 finished. Okay, so now let's look at transaction 5. Transaction 5 start at time 7. Kan it start at time 7 over here. And when transaction 5 finish, so if we take a look, transaction 5 haven't finished up until the crash point. So it means it haven't finished up until the crash point. Okay, so if you got this timeline correct, then you get all 8 marks over here lah. Okay, so this is the recovery timeline for schedule number 1. Sometimes you are given this kind of transaction, you need to describe what the transaction is all about. Sometimes you are given the schedule like this and you need to draw the transaction timeline, so it depends on the question. Okay, so if you take a look, how can we describe transaction number 1? Transaction number 1 finish before checkpoint. Transaction number 2 start before checkpoint but haven't finished. Transaction number 3 start before checkpoint, finish before failure. Transaction 4 start after checkpoint, finish before failure. transaction 5 start after checkpoint, haven't finished. Okay, so this is how we describe the transaction, kan, based on this recovery timeline. Okay, so now let's move on to question number 2. State the value for CT column in transaction 3 if deferred update approach is implemented as the recovery process. Okay, so now this is what I told you just now. So let's describe all the transactions so that you will know what is the immediate update and what is the deferred update approach that is needed. Okay, transaction 1, like I said, transaction 1 finish before checkpoint, can finished before checkpoint. Okay, how about transaction number 2? Start before checkpoint, can start before checkpoint, haven't finished, can haven't finished. Okay, so that is for transaction number 2. Transaction number 3, start before checkpoint, finish before failure, can start before checkpoint, finished before failure. How about transaction number 4? Start after checkpoint, finished before failure. Okay, then how about transaction number 5? Start after checkpoint, can start after checkpoint, haven't finished. Okay, so that is the description for each of the transaction. So now let's take a look what is needed to be done for immediate update or deferred update. Okay, so what does it mean by immediate update over here? When there is a changes, when there's a changes in the database, it will be written straight away to the database. Okay, so that is immediate update. Other changes, it writes to the database straight away. But for deferred update, after you commit, then it will be written to the database. So if you haven't commit, any changes that you made to the database is not yet being written to the database. So that's deferred update. Okay, if you commit, then the changes is written. If you haven't commit, the changes is not written to the database yet. Okay, so if you are in the immediate update or deferred update, immediate update or deferred update, no matter what, if you finish before checkpoint, we do nothing. We do nothing. So means everything is safe. Everything is safe if you finish before checkpoint. It doesn't matter immediate update or deferred update. If you finish before checkpoint, you do nothing. What is it by do nothing over here? Everything is safe in the database. Okay, but for deferred update, it is easier. Let's do deferred update first. Deferred update, like I said, it is easier. Why it is easier? Because in deferred update, like I said, if you not commit, not written to database. Not written to database. So if you take a look, which transaction haven't commit? Transaction 2 haven't finished, So do nothing. Because you didn't commit means you didn't change anything inside database. If you didn't change anything inside database is safe. Everything is correct inside the database. Okay, so that's why we do nothing for the transaction that is not yet finished because you haven't commit. Because you haven't commit, it is not written to database. When it is not written to database, of course there's no changes. When there's no changes, database is correct. Okay, so that's why if you haven't finished, we just do nothing. Okay, because you haven't commit, it will not write to the database. When it is not written to the database, of course everything is safe, everything is correct. Okay, however, if you have committed, so if you take a look, which transaction that has committed, transaction 3 and transaction 4, dah commit. You have committed to the database. So after you have committed the database, like I said, once you commit, for transaction number, for deferred update, once you commit, it return to the database. Return to database. But there is a failure. So if you take a look, there's a failure in the database. Ada crash. There's a failure in the database. So when there's a failure in the database, we are not sure whether what we have written is correct or not. Whether what we have written is correct or not, since there is a failure. So now, since we are not sure whether it has truly been written to the database or not. So of course we need to redo. Okay, so we need to redo. After you have finished, you need to redo. Why? Because we are not sure whether the changes that we made to the database is correct or not, whether it has truly been written to the database or not. So that's why we need to redo. But you have to redo from start. Can you have to redo from start? Okay, so that's why if you take a look over here, if it's a deferred update, you have to redo from start. Okay, so same goes with transaction number 4 lah. Like I said, you have to redo since it has been written to the database. We are not sure whether the changes are truly written to the database or not. Since we have a failure, we are not sure. So that's why we have to redo from the start. Okay, so now let's take a look on immediate update. Like I said, immediate update, if you have some changes in the database, it will be written straight away to the database. Can return straight to database. Can if you have some changes, it will be written straight away to the database. Can so by right, if you take a look over here, for example, transaction number 3, let's look at transaction number 3. They start with the update. Once you update, it will be written straight away to the database. So that is for the immediate update. Okay, so for immediate update, like I said, if you have finished, we have to redo. Same goes. If you have finished, we have to redo. But this one, we can redo from checkpoint. We can redo from checkpoint. Okay, after you have done, you can redo from checkpoint. But if you take a look over here, transaction number 4, they start after checkpoint. So you have to redo from start lah actually. But the keyword is you can redo from checkpoint. Same goes with this one, we have redo from checkpoint. So means you have reduced the start time. Can you don't have to do all the transaction. You can start from checkpoint. So that is the immediate update. But if you haven't finished, you need to undo. If you haven't finished, you need to undo. Undo from most recent logs. Okay, you undo from most recent logs. Okay, so means over here, you have to undo from most recent log until you find the stable point. Let's say the stable point is here, so means you start from here. Okay, it means you need to redo the transaction from that stable point. Okay, so that is for the immediate update. Okay, so now let's take a look on the question again. Can state the value for CT column in transaction 3. So now we are focusing on transaction 3. Okay, we are focusing on transaction 3 over here. Okay, so they said that state the value for CT column in transaction 3 if deferred update approach is implemented as the recovery process. Deferred update, so means kita nak tengok dekat sini. Can we want to take a look at deferred update. Okay, at deferred update. So means deferred update for transaction 3, you have to redo from start. Kan, so if you want to redo from start means, kan, if you take a look, transaction number 3, it starts here. Okay, it starts here. You want to update CT from Jasin to Ceras. Kan, from Jasin to Ceras. So means now we have to redo from start. If it's redo from start, what is the value that is inside the CT column? You have to redo from start. It will go back to the previous, to the old data. Old data is Jasin. So that's why the answer over here is Jasin. Okay, so I hope you are clear. And I hope you are clear why do we get Jasin, not Ceras over here. Because you have to remember, kan, deferred update means you need to redo from start. Kan, if we take a look based on the database, you want to update from Jasin to become Ceras. Okay, from Jasin to become Ceras. However, since we need to redo from start, okay, we need to redo from start for deferred update. So if you take a look, redo from start for deferred update. So of course, at the start, the value is Jasin. Okay, so now I hope you are clear on how to answer this question. So, move on to question number 2. Azri is a database administrator in Toolkit company. Currently, when he is asked to query the data from the database, It took him a lot of time as the system is slow in performance. He tried the query decomposition and optimization for slow performance queries in the system and found out that the query is indeed the main factor. Suggest a suitable query processing technique that suits the company's operation so that the query used is always current. Explain your suggestion. So now if you take a look over here, in database query processing, what does it mean by database query processing? So you have to understand, query processing means we want to process the query, to check whether our query is up to date or not. Okay, so by right, when do we need to do query processing? If your SQL is giving slow result. When you run the query, it took some time for the DBMS to retrieve data for you. For example, if you run the SQL, it took you 5 minutes. 5 minutes to get to the result. So of course you think that it is slow. So that's why we do this query processing to check whether the SQL that we use is really the best SQL or not. Because you have to understand, to get to the same answer, we can do a lot of SQL. But which SQL that will give you the better result, you need to understand by using query processing. Okay, so that's why of course we will choose the fastest SQL. Of course we will choose the fastest SQL. So now when your SQL is slow, so of course we need to do query processing. So what is inside the query processing? First we have the query decomposition, query optimization. So we have the 4 processes: query decomposition, query optimization, SQL restructuring, and also the query execution. You do the SQL execution. Okay, so by right we have 4 different processes in query processing. Okay, so after you have done the query decomposition optimization, we know that the problem is indeed the query. So now, what is the query processing technique that suits the company so that the query used is always current? So remember, query processing technique we have 2. The first one is dynamic query processing, and the second one is static query processing. What does it mean by dynamic query processing? It will carry out the query decomposition. It will carry out query decomposition, composition and optimization every time the query is run. Okay, padam dulu this one. So it will carry out the query decomposition and optimization every time the query is run. So you have the query, for example, you have the SQL. Every time you have the SQL, it will run the decomposition and optimization to make sure that your query is always up to date. The query is always up to date. So that's why if you take a look over here, if you run the query you do the query decomposition and optimization every time the query is run, so the query is always up to date. So means your suggestion is always up to date. So how about static query processing? When we talk about static query processing, you means you choose at which time do you want to run the query decomposition and query optimization. For example, maybe you choose once a week. Maybe you choose once a week. So for example, now you have the SQL, your SQL is slow, but you have done the query decomposition and query optimization yesterday. You have done yesterday. So now when is the next query decomposition and query optimization that you will do? Another 6 days. Because you said that you will do it once a week. So you just done it yesterday, so you have another 6 days. You have to bear with the slow performance for 6 days before you can run the query decomposition and optimization to make sure that the query is up to date, which is the optimum strategy. So this is what we call as static query processing. So back to the question. Back the question, they said that they want to make sure that the query use is always current. So it means always current, you have to choose dynamic query processing. Then you have to explain what is dynamic query processing. You carry out the decomposition and optimization every time the query is run. So when the query is run, the decomposition and optimization run every time means we will always have the optimum strategy up to date. Means always current lah. So that's why the answer is dynamic query processing. Okay, so let's move on to question B. Figure 1 shows the data distribution for customer in Creamy Coffee Company. The database is divided since the branches are not operating in the same time zone. So if you take a look over here, we have table customer. So this is the table. This table customer is divided into 3 parts, which is C1, C2 and C3. So this is the name of the fragment lah. The name of the fragment C1, C2 and C3. So the fragment name. So C1 is located at London. So this is the location. Or the node name. The node for C1. Kuala Lumpur is node for C2. Location of C2 is at Kuala Lumpur. And C3 is located at Sydney. Okay, so this is the customer table, the fragment name, and also the location name or the node of the fragment. As the database administrator, show the relational algebra to fetch all of the customers that is more than 21 years old based on location transparency level. Okay, so the hint is database has birth date column inside the customer table. So inside customer table, we have birth date. Okay, we have birth date. Okay, so if you take a look over here, we have three level of our distribution transparency. The first one, we have the fragmentation transparency. The second one is location transparency, and the third one is local mapping transparency. Local mapping transparency. What's the difference between all of these transparencies? So what's the difference between all of these transparencies? You have to take a look at the fragment name and also location name. In fragmentation transparency, we don't know the fragment name, we don't know the location name. So means if I want to fetch all customers based on fragmentation transparency, I just have to use this kind of query. Select all from, what is the table that I know? Customer. What is the table that I know? Table customer. Table customer. So this is how we query if we are in the fragmentation transparency, because we don't know what is the fragment name, we don't know what is the location name. What we know is only we have the customer table. But if you are in location transparency, you know what is the fragment name, but you don't know the location name. For example, what is the fragment that we have? Select all from C1. Then kita ada second one, select all from C2. Because we have 3 different fragments, we have to query from all of the fragment. Select all from C3. Okay, so now result from C1 kita union dengan result from C2, kita union dengan result from C3. Then we get all of the customers from all of our database fragments. But if you are in local mapping transparency, you know the fragment name, you know the location name. You know the fragment name and you know the location name. So if you want to query the data, there's to be select all from C1 node. C1 dekat mana tadi? C1 dekat London. Node London. Union with select all from C2. C2 node mana? C2 node Kuala Lumpur. Union with select all from C3. C3 dekat node mana? C3 dekat has at Sydney. So this is the difference of SQL if you are in fragmentation transparency, location transparency and local mapping transparency. So the type of SQL that you need to give to the system is also different depending on which level of distribution transparency are you in. If you are in fragment transparency, this is the SQL. If you are in the location transparency, this is the SQL that you need to give. And if you are in the local mapping transparency, this is the SQL that you need to give. Okay, so now let's go back to the question. Find all customers that is more than 21 years old. Kan, more than 21 years old. So how do you know that this person is 21 years old? Remember, we have birth date. Can you have the birth date? Okay, so you have the birth date. So if you want to take the today's date, if you want to check whether what is your birthday, can we take a look sys date minus birth date. Can, if you take a look, sys date is a date, birth date is also a date. If you have date minus a date, we will get number of days. And we will get number of days. From number of days, how can we convert to become number of years? Kan? In 1 year is equals to 365 days. So means what you need to do is sys date minus birth date divide by 365. Then we will have how many years? Kan, how many years of that particular person. So after you have known how many years, then we can make sure that it is more than 21 years old. Kan, more than 21 years old. So the question asks you to give the relational algebra. But if you are not sure on how to do the relational algebra, let's do the SQL first. Kan, for example, what do they want? Select all from C1. Why C1? Kan, why C1 only? Because you are at the location transparency, you know the fragment name. Can you know the fragment name? So this is type of SQL you need to give. From C1, where sys date minus birth date, okay, divide by 365 must be greater than 21. Okay, select all from C1 where sys date minus birth date divide by 365 is greater than 21. So now we get all. Okay, we get all customers that is more than 21 years old. Okay, so now you have to do the same thing for fragment C2 where sys date minus birth date divide by 365 is greater than 21. Then you also will do the same thing for C3, fragment C3. From C3 where sys date minus birth date divide by 365 greater than 21. Then we need to union all of the result. Okay, because this SQL will give you result, this SQL will give you result from C2, this SQL will give you result from C3. So we need to combine all of the result, then we will have all of the customers that is more than 21 years old. Okay, so now how to convert this one to become RA? Kan, how to convert this one to become RA? Kan, select all. We don't do this, select all is not correct. Select all, we start with the selection straight away. So what is the selection? Sys date minus birth date divide by 365 greater than 21 from C1. Union with, we select sys date minus birth date divide by 365 greater than 21 from C2. Union with, we select sys date minus birth date divide by 365 greater than 21 from C3. So this is the answer for this kind of this question. Okay, so by that you have to understand that what does it mean by location transparency first. From this location transparency, then we find Kan, what is the relational algebra? If you know how to do relational algebra, you can straight away give relational algebra. But if you don't know, maybe you can give in terms of SQL first so that you can convert it later. Kan, but of course, I will take a look on the answer of the relational algebra lah, according to the question. But I just deduct from step by step so that you can get to the final result over here. Okay. So now let's move on to the next question. The relational schema below shows the structure of the database of a daily company. We have customer, product, receipt, and staff. Based on the data, there are 3 product types listed, which are cloth, electrical, and also foods. So if you take a look, if you have the DBMS question, so because this is a DBMS question, if you are given the relational schema, please draft the ERD. So if you take a look, receipt is the bridge table. Why? Because it has customer number, product number, and also staff number. So now we have receipt as the bridge table. Then we have the customer. Okay, receipt has relationship with staff, and also it has relationship with product. Okay, so we know that the one that holds foreign key is always the child. So this is the child, and this is the parent. This is the child, this is the parent. This is the child, and this is the parent. Okay, so each day, customers will order the products online through the system. An admin will monitor all the processes and issue the receipt once the order is completed. Since the products are kept increasing due to online shopping trend, the management has decided to distribute the database into few parts. Answer the following question. Describe the fragmentation type if the company has decided to divide the products according to its type. So now we will take a look at table product. Okay, they want to divide product table according to its type. So if we take a look, product types, kita tahu product type ada 1, ada 2, and ada 3. So means if we take a look at table product, okay, if we take a table product, let's say product A, B, C, D, E. So what is the type? Type 1, type 2. This is maybe type 2, this is maybe type 3, this is maybe type 1, and so forth. This is the type because we have 3 different types over here. So means the type over here is repetitive. When something is repetitive, we know that we can do horizontal fragmentation. Kan, kenapa? Yang number 1 pergi dekat fragment 1, type 1. Yang number 2 go to type 2. Number 3 go to the fragment 3. So but if it's repetitive, we can do horizontal fragmentation. So that's why if we take a look over here, describe the fragmentation type. We know how many fragmentation type do we have? It's either no fragmentation, horizontal fragmentation, vertical fragmentation, mixed fragmentation, or derived horizontal fragmentation. Okay, so we have the 5 different types. Kan, is either no fragmentation, horizontal fragmentation, vertical fragmentation, mixed fragmentation, or derived horizontal fragmentation. Like I said, since the type is repetitive, then we can do horizontal fragmentation. So means what do we need to do? We can do horizontal fragmentation. Okay, so what does it mean by horizontal fragmentation? We divide the row according to its type. Okay, what is the column for the product type, which we call as P type. Okay, so this is the answer lah. We can do horizontal fragmentation, which we divide the row. Okay, we divide the row according to its type. So what is the column for the type inside product table? Means P type. Okay, so based on answer in 1, show the relational algebra of the fragments of product table. So now we know that how many types do we have over here? We have 3 different types. Type number 1, number 2, and type number 3. So what you can do is maybe you have P1, P2, and P3. Okay, so how to get data from P1? How to get data from P1? We select P type equals to 1 from which table? Table product. Then same goes for P2. We select P type equals to 2 from which table? Table product. And we select P type equals to 3 from table product. Okay, so this is the relation algebra for each fragment according to the product type inside product table. Okay, so now let's move on to the next question. If the company has decided to divide the receipt table according to its product, explain the suitable fragmentation type. So if you take a look, receipt product, kan, if you realize just now, we do horizontal fragmentation on product table. Kan, the next one they ask you to do the fragmentation on receipt table. Okay, so if you take a look, receipt table is a child to product table. So if you want to do child, kan, if you want to do fragmentation on child, okay, so if you take a look, fragmentation on child after parent table, kan, after parent table, then it will be derived horizontal fragmentation. Kan, it will be derived horizontal fragmentation. So means the fragmentation, kan, the fragmentation, then we will have the second horizontal fragmentation on child based on its parent. Okay, so we do the receipt fragmentation according to the product fragmentation. Kan, so by right, so if you realize, like I said, if you have the next fragmentation is a child of the previous horizontal fragmentation, then we know it has to be derived horizontal fragmentation. Means the second horizontal fragmentation on a child based on its parent table. Okay, so by right, that should be the answer lah. Can, then they said that based on your answer in 3, show the relational algebra of the fragments of receipt table. So like I said, receipt table, since product has 3, receipt also will have 3. Okay, product has 3 fragment, receipt also will have 3 fragment. Why? Because receipt 1 will take from product 1, receipt 2 will take from product 2, receipt 3 will take from product 3. That's why your fragment must have a name. Okay, so now we take table receipt from product 1. We want to find the receipt from product 2, and we want to find the receipt from product 3. Okay, so this is the derived horizontal punya fragmentation symbol. So means we derive the receipt from product 1, derive receipt from product 2, we derive receipt from product 3. So this should be the answer. Okay, I hope you are clear on the derived horizontal fragmentation over here. Okay. In this last question, question 3A, imagine you are the manager of a travel company. List 3 questions that you would like to query to the system to understand your business performance more. So by right, you are a manager. So of course, if you are a manager, of course you will need to know how the business is performing. How the business is performing. Kan? So by right, if you are the manager, what kind of question that you can ask to the database to make sure that you understand your business performance more? Kan, the first one, maybe you can ask, who are our customer? Who are our customers? Kan, because you want to know, if you know who are your customer, then you can produce a product that is targeting on your market, kan, on your customer. Kan, then maybe you can ask which package, because this is a travel company, which travel package is the most bought by the customer. Okay, so because if you ask this kind of question, then you will know maybe you can do a promo on the product that is not being bought by the customer. Kan, maybe you can increase the price of this package, kan, the most bought. Kenapa? Because of why? Because we need to make sure that we can gain more profit, because a lot of people would like to have this kind of package. If we increase the price, people will still go for it, kan. But maybe for the travel package that is not selling well, then maybe you can do some promotion so that people will buy that particular package. So this is the kind of question that you can ask. So maybe the third question that you can ask is, which place is the most booked by the customer? Okay, so since this is the travel company, so of course you want to ask which place is the most booked by our customer. Like I said, maybe we can do some promotion on that particular package, and maybe we can do some promotion if the people are buying ticket for the place that is most booked by the customer. Okay, so any relevant answer I will accept over here, because this is just like a bonus question. Okay, you can ask anything as long as it is related to your travel company and to see what is the business performance of your company. Okay, the next one is describe data mart in data warehouse. Can describe data mart in data warehouse. So like I said, you have to understand this is the process of data warehouse. You have your operational database. Okay, so let's take a look on the database approach first. Can you have so many system and so many users? Can you have so many system and so many users? So this system and users will query data through database. To database through DBMS. Okay, so this is a normal database approach. Normal database approach. Like I said, if you are the manager, if you want to get data from this operational database, why do we call this one as operational database? If this database is being accessed on daily basis. For example, ada orang book. This is this is the booking system. Booking system hari-hari you access database. Hari-hari you put data into the database. You insert new data. Okay, so the data inside operational database is keep changing. Why? Because you access database on daily basis. If you are the manager, if you want to make analysis, the decision that you can make, the decision or the analysis that you can make based on this operational database is short term. Why is it short term? Because of the data is keep changing. Maybe next week data dah lain. The other week the data will be different because the data is keep changing. So that's why in the end, from this operational database, we combine with other sources of database. Then we will do the ETL process. We will do the ETL process and we will load the data into data warehouse. So what is data warehouse? Data warehouse is also a database. It is also a database where it is a data repository where the data is cleaned, standardized to support the decision, integrated, clean and standardized to support the decision making process. So now the manager will don't have to see the operational database to do the analysis. The manager now will check the data warehouse, to do the analysis, and the data, remember data inside data warehouse is historical data. Historical data. So people learn from history. So of course the decision that can be made if you take a look on the data warehouse data is long-term decision. Okay, so remember that. So that is data warehouse. So now we want to ask, what is data mart in data warehouse? So when we want to store data in a data warehouse, the loading process, ETL means extract, transform and load. When you want to load the data into data warehouse, it can be straight into data warehouse. So this is what we call as two tier. This one is what we call as two tier. First tier is operational database. The second tier is data warehouse. However, you can also have the operational database. So this is your operational database. You didn't load data into data warehouse straight away. You load data into data mart first. From data mart, then we load data into data warehouse. So this is what we call as three tier. First tier, second tier and 3 tier. So what is a data mart? Data mart is actually a subset of data warehouse. Combination of data mart will make it as a one big data warehouse, because sometimes you have a few departments, maybe HR departments, you have finance departments, maybe you have sales department. Each department can have their own data marts. Each department can have their own data mart. Combination of this data mart will make one big data warehouse. Combination of this data mart can make one big data warehouse. So what is a data mart? Data mart is a subset of a data warehouse. Okay, so that's the answer for question B. So now let's take a look on 3. Explain 3 requirements needed for data warehouse DBMS. So you have to remember, data warehouse is also a database. Okay, because it is a data repository, means you store the data. So when it is a database, so of course you need a DBMS. But what are the requirements for the DBMS for data warehouse? The first one is load performance. Why load performance? Load performance means when you want to insert the data into data warehouse, the performance must be good. Why the performance must be good? Because data is huge. Okay, then the second one is load processing. Okay, so when we talk about load processing, if you want to load data into data warehouse, it must be done periodically and only involve change data. Okay, so why it must be done periodically? Because of, like I said, if you access on daily basis, that's operational database. Data warehouse is not something that you will load every single day. Maybe once a week, once a month. Why? Because after you have sales of the week, then we analyze the sales of the week, then we load the analyzed data into our data warehouse. Because like I said, data warehouse is not being accessed every day. Okay, so it must be done periodically. The third one is data quality management. You have to understand that DBMS for data warehouse must have a data quality management. It must give user precise result even though data is huge. Okay, then query performance. The ad hoc analysis must not be slow, because sometimes as a manager, maybe you want to query data from data warehouse at instant. So the query performance must be good. Why must be good? Because of the data is huge. So you need a good query. Okay, then terabyte scalability. You have to remember data warehouse is a big data repository. So that's why it must have at least terabyte scalability. You can size up or you can scale up the data warehouse size when needed. Then mass user scalability. You also have to understand that data warehouse will be used by the managers, and you want to only have one managers inside your system. So number of users can be increased without affecting the performance. Then the next one is network data warehouse. What is it by network data warehouse? You also have to understand nowadays we will not be in our company all the time. So if you let your data warehouse to be accessed only by intranet, so of course it will be hard. So network data warehouse means it can be accessed anywhere, anytime. Warehouse administration. So you have to understand also, since data warehouse is also a database, you need a data warehouse administrator. So the DBA must be ready all the time to support any operation in the warehouse. Okay, then the next one you need to also have integrated dimensional analysis. So you have to understand that you can do a lot of analysis according to data warehouse, and one of it is a dimensional analysis. So data representation can be done from the data warehouse. And the last one is advanced query functionality. Any advanced query by the user for calculation and comparative analysis can be done, because like I said, from this data warehouse you have to do a lot of analysis. For example, so this is the sales and this is the product. So maybe you want to compare between, this is 2021, maybe you want to compare with 2022 and so forth. So by right, there will be a lot of comparative or calculation that is needed to be done for the analysis inside the data warehouse. So these are all the requirements needed for the DBMS for data warehouse. Okay, then let's move on to the last question. Okay, so study the following data warehouse schema. So we have sales product, and staff. Like I said, if you are given relational schema, the easiest one for you to do is draft the ERD. Can draft the ERD. So which one is the bridge table? If you take a look, sales product. Why? Because we have sales ID, product ID. So you have sales product over here. It has relationship with sales. It has relationship with product. Okay, then the next one we have table staff. Staff is related to table sales. Okay, so this is the draft of your ERD. So this is the parent, this is the child, this is the parent, this is the child, this is the parent, this is the child. So if you take a look over here, we have two different child, kan? So if you have two different child, of course this is not a star schema. Okay, this is not a star schema. Okay, so now let's take a look on the question first. Okay, so the schema above shows how some data is being organized in a data warehouse. Answer the following question. State the fact and dimension table. Okay, so now you have to understand what is a fact table. Fact table is something numeric. Something numeric that can be calculated. Okay, then what is the dimension table? Something descriptive. What is by something descriptive? Something that we can describe. Okay, so if we take a look inside sales, is there any numeric table? If you take a look, yes, total sales. Total sales is a numeric table, then something that we can calculate. So this can become fact table. Then product, is there something that is calculated? So if you take a look, this is just a description of the product. This just a description of the product. So this is a dimension table. Then how about sales product? We have sales ID, product ID, something descriptive, and quantity, something that is quantifiable, means something that we can calculate. So means this is also fact table. Then the last one is staff. So this is all something that we can describe. So this is a dimension table. So now if you take a look, we have two different fact table and two different dimension table. Okay, so what is the fact table? Sales and also sales product. So what is the dimension table? Staff and also product. So this is the answer for question number 1. Then explain the roll-up model that can be represented by the data warehouse schema. Okay, you have to understand. We have OLAP server. OLAP server kita ada 3 that we cover in our lesson. And the first one is relational OLAP. We have the multi-dimensional OLAP and combination of ROLAP and MOLAP, which we call as HOLAP, hybrid OLAP. Okay, ROLAP is represented by star schema, which we can extend to become snowflake or constellation schema. Which we can extend to become snowflake or constellation schema. Then how about MOLAP? MOLAP we have data cube. Data cube has few operation, which we have the slice, dice, roll up, drill down, and also pivot. Okay, so if you take a look over here, it doesn't matter you want to do the star schema or data cube. First, you need to determine what is the fact table, what is the dimension table. Okay, so just now we have done doing the fact table and dimension table. We have done on this part. But the question asks you to explain the roll-up model. So now roll-up model. So we doesn't need to look at roll-up ataupun HOLAP. MOLAP or HOLAP, because the question asks you for roll-up model. So explain the roll-up model that can be represented by the data warehouse schema. From this schema, what is the suitable roll-up model? We have 3: star, snowflake, or constellation. What is star schema? Star schema we have fact and the rest are dimension. So this is star schema. Then how about snowflake? When it was snowflake, same. You have one fact table and the rest are dimension table. However, when you have dimension to dimension relationship, so this is what we call as snowflake. Okay, you have dimension to dimension relationship. So that's snowflake. How about constellation schema? Can it start with star schema also? Can it start with star schema, which we have dimension. Okay, then maybe you have dimension to dimension, but you have more than one fact table. Kan, if you have more than one fact table, so this is what we call as constellation schema. Back to the question. Can explain the Roulette model. If you take a look, you have two fact table. Which one suits the explain the Roulette model? Star schema tak boleh because it has only one fact table. Snowflake also cannot because you have only one fact table. If you have more than one fact table, the answer is constellation schema. Why constellation schema? Because the schema consists of two fact tables. So that should be the answer. Okay, that should be the answer. Okay, so now they ask you to draw the Roulette model that you have explained in two. Can we have done the draft? So it is time for you to do the schema. Okay, sales product. So what is inside sales product? Okay, inside sales product we have sales ID, product ID, quantity. Sales ID, product ID, quantity. Sales product has relationship with product. Okay, so what is inside product? Inside product we have product ID, product name, product ID, product name, product price, and product expiry date. Okay, so what's the relationship? The fact table will always have many sides, so it is one to many. The sales has relationship with, sales product has relationship with sales. Okay, so what is inside sales? Kita ada sales ID, sales date, total sales, staff ID. Sales date, total sales, and also staff ID. So what's the relationship? The fact table will always have many sides, one to many. And sales has relationship with staff. Okay, so what is inside staff? We have staff ID, staff name, staff salary, and staff email. Staff ID, staff name, staff salary, and staff email. So what's the relationship? Which one holds the foreign key? This is fact table. Fact table has many sides. Okay, so remember this is not ERD, this is constellation schema. Kan the modality over here yang macam new one ke zero ke no need. Kan, because this is not ERD, so this is constellation schema. Okay, the fact table will have many sides. Okay, so that's the answer for this Roulette model. Okay, so we have discussed everything in our test 2. If you have any question, you can directly ask me, and you can also contact me if there is something wrong lah with the marks on your test 2. So if I mark it wrongly also, please let me know. Okay, so I guess that's all for now. Thank you. Assalamualaikum.